EdgeLink software, which is Advantech's solution for collecting data from edge devices or sensors themselves, then to process the data. You can store it either on the EdgeLink device itself or push it to the cloud, or some combination of both of those things. Within the EdgeLink software, we are going to talk about the three different layers that the architecture takes on. At the lowest level is that collection of data. Like I said, you can collect from small devices like Advantech Atom or WISE modules, or anyone else's open architecture type sensing devices. This also supports devices directly, or sensors directly, in the form of voltages or digital inputs and digital outs on some of the more advanced EdgeLink products. And then you'll see here in the middle layer, we can pre-process that data coming from those sensors, either to scale it from raw values into engineering units, or to perform logic manipulations, even a full-bore soft PLC product that exists on one of the variants of the EdgeLink products. And then at the upper layer, you take that data and can push it into various clouds, whether that's your own SCADA or private database, or a public cloud, Azure, WISE-PaaS, NSAS, AWS, those sorts of things. So to give you a brief feeling for what we're looking at as far as configuration, we will be looking at the primary configuration conduit for EdgeLink, which is known as Advantech EdgeLink Studio. This is a Windows-based application. Upon opening the Windows application, you will see what I'm seeing on my screen, which is a dual pane view. Up at the top, you'll see the toolbar, and importantly, we'll note the download button for later use. On the left-hand side, the project tree. And then on the right-hand side is an action information pane. And down at the bottom, you can toggle two of the functions of this program, project view and monitoring online, once you have your project running on the runtime. So we will begin by creating a new project over on the left-hand side in the toolbar. We'll just give our project a name. I'm going to name it the same thing as the hardware that I'm using in this case, which is the Atom 3600. Then we need to add a device to our project. You can have many devices within a project, but we'll just have one this time around. So right-click and add. And we'll just generically call this the device. We will fill out the model, and here you can see all the various models this software supports. The topmost option is what we need. And then you can give the software the IP address of your unit. If it's DHCP like mine, I'll just fill in the information that was given to your unit when it was powered on and plugged into the network. And then we'll give it the time zone. Not too important for some functions, but the cloud function will need to know what time zone you're in so that the time all lines up correctly. And then apply that to the project. From in here, you can see the data center, and that's where we get the collect layer of everything. The local I/O, or in this case a TCP device. Let's hop in here to the I/O tags. These are the directly sensed pins on the top and the bottom of the Atom 3600. And you can enter these various data points, tags if you will, and you can span them if you needed to, or give them some other kind of scaling formula. There's quite a few to choose from. That would turn your engineering units, turn your sensing into engineering units. I won't modify anything at this point. If you wanted to add a third-party device or one of our Atom or WISE modules to the Ethernet port, you could right-click on TCP, give it a name, select from more than 200 various sub-devices, or drivers, there to choose from. Most basically something like Modicon, Modbus TCP. Fill in various pieces of information to uniquely identify that particular slave. And then, well, if I was going to continue with this, I could just apply it but in this case I'm not going to use a slave device, so I'm just going to throw it away and discard it. So we'll look at calculation tags next. Calculation tags are the pre-processing or manipulation of data. So let me just create a quick tag known as 5 minutes. It'll just be a 0 to 299 value. And I'll generate that up off of the built-in system current time. If I just divide that and get the remainder from it, mod 300 if you will, that variable will just count up from there. And we'll move on to, a little later in this video, we will enable KW and download a project. So I need to enable that so that the KW Soft PLC embedded runtime is actually running. We'll save our project, and then we'll click on the IP address of the project so we're at the root of it. And then we'll download to the device that's running on my desk. It compresses the project for transfer, and then sends it over. Service restarts on the device itself. It's not actually rebooting at this point. And now we're done with that. So I can close all of these windows. Alt-tab over to Multiprog, which is also a free piece of software for the Atom 3600, which allows you to do soft PLC programming. And create a new project. I'll give it a name, generic name. I'll make a function block diagram out of this particular project and make sure that my type is set to TagLink, which is kind of an older name for EdgeLink, but still how this program treats them. And then we'll use a cyclic task. A task in KW is the looping runtime that will run your logic. So we'll wait for Multiprog to spool up all of its files and present you with a blank worksheet. We'll hop over to the Hardware tab and open up the Advantech EdgeLink conduit and open up the project that we created previously when we saved it. And this is how it knows what tags you need in order to manipulate your logic. So you can see all the analog inputs, digital outputs. And we'll create global variables out of those tags automatically. You just click the button, exit the dialog. You can go into the global worksheets, global variable worksheet, and see all of those tags auto-created. We'll go into resource and we will set the IP address so that the development environment here knows how to download into its particular runtime service on the unit. Hit OK. Then we'll go into the project worksheet where we define our logic. Open up the main cyclic task, and we'll just write a really simple examine an analog input. If it's higher than a certain value, we'll drive an output. So I'll select the first analog input. If it's greater than from our toolbox, then define a constant, some low voltage. Hit OK. The output of this particular logic block will set to a digital output. Now we can make our project from the toolbar of this application. This takes a bit of time. You see in the lower left hand corner as it spools through the messages. If I had any errors, they'd pop up in that window. And we had success, so I'll choose project control, very much like project download in the other. I will stop the existing runtime. And we'll download my new logic. And then basically hit go with the cold start function. So now it's running in a loop. I'll debug it so I can see the live values. And there's a really tiny, almost 0 value on the analog input. Let me jump that up to 2.5 volts. There we go, 2.5 volts, and the digital output fires. And I can see that as well on my unit. There's a LED that indicates output status. And as I toggle back and forth between 0 and 2.5, my greater than block feeds that. Let me tab back over to the EdgeLink Studio application. Choose Monitor from the toggle at the bottom and search for my device. I will be visiting the web page that's hosted on an EdgeLink product. It basically allows you to manipulate the live values of the system, see logs, reboot, update. So I'll sign in with the default password of 8 zeros. Starting off with tag view. The IO tag is part of the collection process. There's my analog input. I can again drive a value into that. There's 2.5 again. There's my digital out. My digital out's still being controlled by that KW block that I put in on this Atom 3600. Toggle it back down to 0. Here's the information pane where you can see the system log, all of the various services punch out their data if they have something to say error-wise or success. That will show up in these lists. From configuration, I can set the time. There's also a service to auto set the time from an NTP server. I can reboot the unit, and on the last pane I can update the image or the binary that makes up the EdgeLink software for when updates come out. So far we've reviewed how to collect data using Advantech WISE-PaaS EdgeLink, and then how to pre-process that data through a simple calculation tag, and also in this particular instance the Atom 3600's embedded runtime, KW. So let's push that data now up to the cloud. We'll use the Advantech WISE-PaaS NSAS product to do that. You could use Azure or AWS if you want. I'll put a little link here, show it on the screen for how to do Azure and the basic configuration of WISE-PaaS itself. It can be a bit difficult to go through the creation process of creating a WISE-PaaS account, and I'm not going to go through that in this video. That would make it twice as long. So I've just copied over some basic values, credential keys, URLs, just some basic data that this unit needs in order to be able to upload it. And then I click on which tags I want to import into the cloud. I go ahead and hit OK. I've already done that, so I'm just going to hit cancel on this box. Apply it and download it. Then I will tab over to Chrome. I already have the WISE-PaaS NSAS portal open. And that's the URL, long string of numbers that gets used in a couple different locations within the dashboard function that we're going to go visit next. Before that, let's check on those tags that I enabled in the EdgeLink software. So buried in the tree here in the project and then the SCADA node, you'll see the two varying values. The 5 minutes tag that counts up to 300, and then the analog input, which I can drive a voltage into. I can drive 2.5 volts, 5 volts. It's got about a 6-second delay. That's just what I had it set to. Here's the dashboard, Grafana, and I will add a data source and paste in that URL that we saw earlier in the cloud setup, just an arbitrary number. Create a very basic dashboard with a graph. Import one of those tags. It's hierarchical in nature, so you have to select your project, that SCADA node again. If I had more than one device, there'd be more than one device in this drop-down, and then that 5 minutes tag. counts up to 300, then drops again. Give my dashboard a name. Make the data a little less squished on the right side here. I'll just do the last hour of data. And we'll have it refresh continuously every 5 seconds. Also, we will add a panel for that analog input, the raw voltage. Same deal, go through the hierarchy to find the project, the node, the device, finally the tag. We'll give Grafana a little bit of information about what we're trying to gather here. Get the current value from that historical data set. And scroll to energy and volts if I can find volts in the list. There it is, down towards the bottom. And tell it I want 2 significant decimal points and a nice graphical gauge. Save and apply that. And view the totality of our very small dashboard. I'll vary the voltage and wait maybe up to a combined 11 seconds, 5 seconds update here, 6 seconds there. Oh, there we go. Can drag and drop our dashboard. So there's the very simple ability for EdgeLink to push up to the cloud. Thank you for watching this video.